Welcome everyone to Drake's Lounge, Australia for October. I think we've sorted out the time zone differences just about, but this is our regular monthly get together with predominantly America and the southeast of Australia. So we've got representatives from South Australia, Victoria, Tasmania, New South Wales. I'm trying to find some time to expand our reach to some other states, but work keeps getting in the way. But I'll keep working on that and trying to expand it. So I'll go around the audience on my screen, but I'll start out with my own quick update, which is to do with a paper I'm going to give to the physics teachers here in Melbourne of a network, physics network. Physics and physics, that's senior physics, year 11 and 12, but also year 7 and 10 in schools, the component of those courses. And my topic is space weather. I've mentioned this before. It ties in with a lot of what Andrew is doing there. I think there's quite a wide range. I do a U3A astronomy course, and I did a quick overview of space weather and the implications for solar activity, implications here on Earth. And it's scared the living daylights out of them because of the implications of what could happen if we got the right bombardment of whatever radiation is coming along. So I'm going to put together PowerPoint, which I'll share with this group once it's ready. And my idea is to point them in the direction of free or low-cost resources that schools can use there. And there are quite a lot of resources out there that people have put together for schools, which is really good. And I thought also I might mention some of the SARA activities, including the grant scheme, because I think certainly the government schools here are always short of cash. And so I'm trying to find ways that they can do solar emissions and so on, get into space weather for free. But there may be something in the SIDS, for example, in the SID area, where they would have then apply for a grant, and we could have more of these SIDS systems set up around the place. I think that would be a good thing overall. So that's going to take place in December. So I'll use November to get the resources together. If anyone's got any ideas of things that I could include in there, Bureau of Meteorology has a space weather section in its website. What I've found is it's somewhat out of date. You try and click on links and they don't go anywhere, or they go to stuff that's way out of date. So I thought I might get in touch with them and see if there's some update could be undertaken that we might contribute to. And then there are equivalent sites in America, the NOAA sites and so on, which are, I think, kept up to date more. And I'm linking it to the Aurora that many people have been enjoying. And Andrew, I don't know whether you're far enough south that you'll be getting lots of Aurora down in Tasmania. But the Aurora have been going all the way up into, certainly right through Victoria and up to New South Wales. And they've been quite magnificent. Relating to an active sun, 11-year sunspot cycle and all those sorts of things. I think I've read two dates for what they regarding as the peak of the sunspot cycle, January and May of next year. I don't know why. Is it whether we just wait and see when the activity starts to die down? So you do it in retrospect. We say, when was the peak? It was back then because it's on its way down. So that's my focus for the next little while. That'll keep me busy. And as I say, I'll share what I've got with this group and welcome comments or fine tuning before I actually make the presentation in December. The presentation will be at a pub, which is good. I don't know whether we have the beer beforehand, before the presentation, or afterwards. It's quite a good venue. It's a regular monthly spot that particular network has. So that's all I have at this stage. And going around my screen on the Australian side, Andrew, you're lucky first.
Thanks very much, Paul. And yeah, it'd be great to hear the outcome. I've got a few ideas I could suggest to you for some simple space weather things. In fact, I might even have some things here that are kind of relevant. So I'll attempt to share my screen.
You're welcome.
So just a quick summary of some observations over the last month or so. And the first one was the annular solar eclipse on the 2nd of October, which, while not necessarily a radio astronomy activity, uses radio astronomy techniques, or at least I've used those here. I guess folks in the US really didn't see any of the partial phase. Maybe Richard out in Hawaii might have caught it at dawn. But I was monitoring WWVH, which is near Richard, and WWV up in Colorado near Rich, and measuring the Doppler shift as I do each day using little Spy and SpyVerter combo with a GPS DO. And I'll use this with the neutral hydrogen measurements that I'm working towards with my small dish shortly. But looking at the eclipses are interesting. They produce ionospheric disturbance or changes in the ionosphere, and there's still a lot of science to be done. The Ham-Sci group in particular has been doing a lot of work in this area and have been coordinating observations around the globe, and encourage you to check that out, so particularly for future eclipses. So here are the circumstances of the eclipse, the annular path across the Pacific Ocean, largely not crossing land or any land. I'm over here in Tasmania at about 42 south, looking at these two propagation paths. The WWV path crossed some of the partial phase, not much for WWVH. So in the next slide, I have a comparison. 3 days of observations. The blue line here is at 17 UT, which is when the maximum partial phase would have been across the WW path. So these plots here are what are called Dopplergrams of the 15 megahertz signal. It's showing here frequency versus time. The zero Doppler shift is along this line here. And as the ionosphere varies, moves up and down, or changes its refractive index, you get spread of the signal. The bottom panels are the amplitude across this band. So this is the day before the eclipse, this is the day of the eclipse, the day after. Maybe there's something happening in here a little bit different to these other 2 days, a little bit of a day in the signal. Perhaps this is the ionosphere being more like nighttime ionosphere rather than the daytime ionosphere. Still got some more analysis to do on this, because what you really want to do is you want to compare many days and actually look at some of the deviations from the average. It's an interesting spread happening in here. These could be ionospheric disturbances. I thought, this is a little bit different for this particular day, but then I'll look actually on the 4th and there are some similar features. So again, you've got to compare a number of different observations before you start to tease out some of the details. But the sort of things you might expect to see, as I mentioned, the ionosphere going into its nighttime mode, so a change in the height of the ionosphere, shifting up or down, which would cause a Doppler shift here. So that's the eclipse. I like monitoring these things. Never know what you might. The sun's been pretty active, as Paul mentioned. In fact, we probably are pretty close to solar max at the moment. And this was a particularly interesting flare on the 9th of October, since preceded the Aurora activity that Paul alluded to, with my wind radio SDR and the Lupin Terrae baseband of 50 megahertz with relatively low time resolution, but this is spectrogram, particularly strong solar burst, showing some different types of emission. Type 3 rapid burst here, maybe some type 4 emission on these descending bands of type 2, which are due to a shockwave moving out through the corona, and this is actually the coronal mass ejection as seen in radio. The spectrum over here is actually this small section in here. This is essentially it's like a radio Jove, 16 to 24 megahertz bandwidth. Monitors mainly for the Jupiter burst, but also the sun pops in there from time to time, and it's got a high time and frequency resolution. Up here, one interesting thing, so this particular burst produced a very long duration continual emission of 140 megahertz. Still often see such a strong, long-lived burst, and this is the corona being disturbed and just emitting radio waves continuously. Again, a good indication of big coronal mass ejections heading right towards us. This is, I think, synchrotron emission beam towards us. Again, another indication that things are happening in our direction. So that was a nice event, and a couple of days later we got this great aurora. A few different things I'm showing here. So the Doppler measurements, the 15 megahertz Doppler, are pretty useful for seeing disturbances of the ionosphere from geomagnetic storms. So this is the arrival of the coronal mass ejection at the ionosphere, or actually it's probably more the effect of it on the atmosphere, the magnetic field lines being twanged by the arrival of the shock front. And the change in that magnetic field causes currents in the ionosphere, which cause it to essentially ionization to move up and down, producing a Doppler shift. And this is the arrival of the seeing. When you compare these sort of measurements with magnetometers, the horizontal component and the vertical component of the Earth's magnetic field show some nice relationships. So these measurements, 15 megahertz Doppler, Doppler are quite useful as a proxy for what's happening in the geomagnetic field. I've got an all-sky camera in the backyard, and this is around 1655 UT, so a little bit after this arrival, when the energy in the geomagnetic field is ramped up, and we got Aurora. So overhead is here. For the folks in the northern hemisphere, of course, we saw Aurora from the south going north. And of course, you'd be seeing it from the north going south. So overhead in Tasmania at 42 south. And in fact, this plot down below, which is essentially the north-south slice stacked in time, kilogram. I think a guy called Professor Bob Ether, coined the term kilogram way back. Bob was actually part of the program I used to work for way back. He entered in Antarctica with our program. This kilogram here, stacked along here, shows the Aurora in the early morning, just before sunrise on the 10th of October UT. This is the 11th, our local time. And it may actually pass the zenith well to the north for a period. I was lucky to be outside with my dog. Got to see this great red colour in the sky. So quite impressive. And then the next evening, we got a bit more before the cloud shine. And then finally, just a burst the other day, which is kind of interesting. There's another big sunspot region, or quite complex series of sunspots coming around. Seems quite a strong X-ray flare. I got this one kind of late in the day for me, a couple of hours after solar transit. But again, showing you kind of what you can see with different techniques. Doppler measurements here showed what's called a sudden frequency anomaly, which are due to birefringence in the ionosphere as the extreme ultraviolet and X-ray emission changes the refractive index of the ionosphere. These are quite a good proxy for hard emissions, shortwave emissions from the flare, and then you get into shortwave fade out, which is the X-ray emission, basically causes the ionosphere to become quite absorbent. This peak of flare was seen right down to about 10 or 11 megahertz. For me, the limiting factor is the ionospheric cutoff and some quite strong emission around sort of the HF and the VHF band, which I think this event again has produced a little bit of a CME heading towards us. Perhaps we'll get a glancing glow and get going. So that's it from me.
Excellent. Thank you, Andrew. And as usual, nothing gets past Andrew's observatory there. Lots coming in, lots happening, and very well explained as well. Thank you, Andrew. And I should say thank you to Andrew for hosting the Australian End last meeting while I was off in another state. And talking of the annular eclipse, Rob sent his apologies to the meeting. Where is he? He's in San Francisco. But he sent a couple of pictures, and I'm going to try and share them. But my second screen is not working very well, so I'm going to have to do it on here. Share this screen, and then bring up that picture. So that's the annular eclipse, the picture that Rob sent, and I'm assuming that's one of his, because he is a keen eclipse chaser, and that's, I forget exactly where he was when he got that. That's one of his pictures, and he also sent, find it, he sent a picture of the comet as well that he'd picked up. Just bear with me a moment. That's not Comet. Still loading. There it is. That's Rob's picture of the comet. I don't know whether anybody else has managed to see it. It's apparently it's now visible in our evening sky in Australia. But I haven't got around to actually taking advantage of the presence of that comet. Phil, is there any viewing from Heathcote that would help with seeing the comet? You haven't seen it? Your microphone, you have muted. Yep.
Yeah, no, I haven't actually been looking. I've been doing lots of other things.
Yeah, I'm sure. I'm told it's in the evening sky, and you'd have a good chance of seeing it with these clear nights. So it might be worth a look if you do have time. And Phil, you're the
binoculars is pretty easy to find.
Yeah,
just a quick look in binoculars in case you don't get another one for 10 years.
Yes, and I think binoculars makes a big difference, definitely. And Phil, on my screen, you're number 2. So if you want to give us an update on the dish and what else?
Yeah, personally, the dish seems to be my focus at the moment. There's a few other little projects up here at LMDSS that I am working on. We've just recently installed a sky quality meter, which is for the optical observers, but the radio astronomy section gets the custody of all these electronics things for some reason. In any case, yeah, the work is still fairly slow for getting the dish up and running, but we are ready to start installing the electronics in the focal point of the dish. So it's all getting quite exciting at the moment. But on a second sort of note, Richard would be really interested in this one. We have a young chap here by the name of Nathan Scott. I'd met him a couple of years ago. He was in year 10 at the time, I think, or year 9. And he was already doing university courses on the side. So he was a bit of a smart chap. He's 17 now, I think. He's doing a science experiment or a science fair that he's going to in Indonesia or somewhere like that, or Malaysia next year. And he asked me, what can he do? And I thought, there's a section in the back of listening to Jupiter, which talks about calculating the power that's produced on Jupiter. And by measuring the antenna temperature, you past that antenna temperature through the how far away Jupiter is, et cetera, et cetera, et cetera, and you get the isotropic power. And I said, do that for me. And off he went, and he's writing code in Python. We received Jupiter on an older analog style receiver. We create antenna temperature from it and chart it on a Python program. And he's now working on producing the isotropic power of Jupiter, and when the sun is up, the isotropic power of the sun for when there's flares. So I'm looking forward to see how far he gets with that, and he's starting to achieve his goal. Oh yeah. Hope to
Great.
report how well that goes.
You gave him a good problem.
Yeah. He's definitely taken it on board.
Thank you for doing something with it.
You're welcome.
So the dish, Bill, is it now steerable?
Yes, it's operational. The motor drives are up and running, and I've parked it in the maintenance position, which is to the horizon, pointing north. And the scaffold is half built. I just need to wheel it around and build it up to the actual focal point. And then not next week, but the week after, I think we're due to come up again and start working out what holes to put into the actual box that we have at the top to mount the receivers and the noise source and all the equipment that makes it all work. So yes, exciting times.
Steve has shown a lot of that to this group, I think, and his testing and so on. The main test will be, once it's mounted, is it going to do what it's supposed to do? So it's been a long story. Sounds like the group is getting there. And we look forward to an update and seeing some data come from the dish, not too distant future.
Yeah, I'm hoping to list in the new year.
Yes. I know that our Northern Hemisphere friends are looking forward to some Southern Hemisphere data. So there's the challenge. So is that a lot from you, Phil? That's all?
Yes, that's all I have.
Good. All right, thank you. Looking around on my screen, Len, you're the next lucky person.
I haven't got anything to report really. I've been tied up with other things, but with regards to space weather, there are some recent CubeSat launches where they're monitoring various physical things in the atmosphere to monitor space weather. So I don't know if that can be part of a student project as well. Depends if the data is available. But that's all I wanted to say. I've just been busy with work.
Yeah. There are certainly sources of secondary data which students can access. And then the next challenge after that would be to set up their own system. So they're collecting their own data and analyzing it. But
one thing that I've been thinking about in the background is, because I've worked on phased arrays for radar, is there an advantage in having a little phased array feed or a radio telescope where you could shape the beam to sort of reduce spillover and perhaps even do a bit of steering using the beams, so you could go blink every now and then? I don't know. You could build it using some software-defined radios anyway, it was just a thought. Yeah.
It's certainly
because I know CSIRO do that with the square kilometre array that got a phased array feed.
Yep.
Could we build a simple one for amateur radio astronomers?
I think all of this stuff comes down to getting funds to put it all together. But it may be that we're able to fund something that we as a group put together here, which would then be put out and borrowed by schools whenever they need to. Andrew's mentioning loop antennas. I mean, loop antennas, that's a quick trip to the hardware shop, and it doesn't cost very much at all to put together a loop antenna. That's certainly a place to go to get some practical data collection. And it may be that we're able to get some cheap software-defined radios. Some of the LTL software-defined radios, they're not expensive. And I'll put the presentation together, run it past this group. Then in December, I'll get feedback from teachers themselves as to what's feasible for them. I know they're short of time, they're short of money, all those sorts of things, but we can provide support mechanisms, perhaps some gear that they can borrow. Then there may be some potential in that. Well, let's wait and see. Okay, thanks, Glenn. Yep.
For multiple antennas, there's a number of people that are doing two element interferometers and 3-element interferometers, and combining both analog and digitally. Wolfgang Herrmann up at the Astropeeler's got a 3-element interferometer. He's been combining with a digital technique, the IQ combining. And then Ted up in Colorado has done it analog. He's just tied the feeds together analog wise. Of course, you have to worry about how you're going to power the LNA doing that, but he's been able to do it analog and use a standard hydrogen. Well, they got these little beam antennas that they're using. Yeah, the 2 and the 3-element interferometers, there's a lot of info on those. Phased array, they're not phasing them. They're just using interferometry techniques.
Yep.
But I think that there is somebody who talked about interferometry, or phasing them a couple of months ago, and I don't know exactly where that is on the videos, but that would be very interesting to do phased array. And that would, if we can get a nice cheap version of that we can use for amateurs, that'd be wonderful.
Yeah, because if you synchronize the clocks, and you can buy disciplined oscillators, so you can have clocks that are synchronized across distance using the GPS signals to, and certainly for lower frequencies, that would work. Yeah, anyway, it's a thought.
Yeah, certainly a lot of potential in that area. And my approach is, I'm sorry.
There is a synchronized local oscillator array of SDRs called the Kerberos, Kerberos. I think it's 4 or 5 SDRs in the same package, and they're all synchronized to the same LO clock. That would be a possibility for something like a phased array. I think they use the earlier version of that. Uses one of the SDRs to get the other 4 going, and then they have 4 antennas on it, and they've been able to use it for direction finding and things like that. That would be a possibility with, say, 4 dipoles to get a phased array going. I believe you said as an antenna feed, which would be a very interesting project. I don't know, 4 bow ties or 4 dipoles in a square. I have no idea what that would have a better beam shape or not. It's hard to say. Yeah, there it is.
SDR.
It's a bit spendy for or just piddling around to down and think out and maybe think out the possibilities. It might be worth doing. I have no idea.
Yeah, I'll have a look at that anyway.
Yeah. What's interesting is that the Astronomical Society of Victoria has its dark sky site out of Melbourne, which is where Phil is at the moment. But they're also working with the local racecourse, Caulfield Racecourse, to set up in the middle of there's a public park in the middle of the racecourse. And, it may be that we can set something up in that area because it obviously doesn't require the dark sky site and might be accessible by a wider range of people. Phil, do you think there might be something in there?
Possibly, yeah. Keep in mind, they've also got another property, another 2 hours from here in the northwest of Victoria. So they could set up quite a few different places.
Put some and get remote access to it. Yeah. As the Caulfield Racecourse has the advantage that public access is much easier, and we do have public sessions, and that would be a real opportunity to set something up which is not optical. Anyway, so many ideas, so little time, as always. I'm going to go around on my screen. So, Michael, you're next off the block, and I can see your highly sophisticated antenna steering system behind you, the wheelbarrow.
Yep, that's I'll just share my desktop here. I was out camping in country Australia at the ASNSW's property at near Mudgee, and mobile service was pretty grim. So I had a bit of a brainwave and scrounged around and found a satellite dish. Am I sharing, by the way? Yeah.
Yes, that's
Found
right.
a satellite dish that you can see has been sitting partially covered in the dirt, and rolled it. I don't know. It's about a nearly 1.8 or 1.6 diameter. Found an old wheelbarrow, a rusty old wheelbarrow. That's now my mount. And these structures here, which I don't know what they're called, they were rusted to buggery, and this one was missing. So I just got a bit of rope and tied it around here, and then used a tent peg to tie it into the ground to give it some tension. And then I mounted my mobile phone here and pointed this, using the mobile phone up to find out where the tower was. Then I mounted my mobile phone here at the focal point, and I was camped 5 meters away from here. And that was enough to give me 2 bars from zero, maybe 1 bar from
Bush
no bar.
mechanic.
Yeah, exactly. So it worked, and it cost me nothing.
And the hat is the cooling system, is it?
That's right, because the mobile phone's sitting there right in the sun, and it's going to get cooked. So the budding spat served as a shield for that, yet it's radio transparent. It was a great day. Probably put down a bottle of rosé while I was thinking of all of this and assembling it, and then enjoying 2 bars of internet for the rest of the day. But anyway, that's just a bit of fun. And so I've been kind of offline with my entire life for the last year, because we've sold our house in Sydney and moved to country New South Wales, up at Gloucester, which is an hour and a half north of Newcastle. And we've got an acre property here, so I've got to ask very nicely whether I can put a radio telescope on the property, as in ask the wife, or make sure I've planted enough trees to hide the thing. It won't look like this, so I don't know where to start, although I did find at the tip satellite dish and it's probably about a 1 meter diameter, with a tripod that would normally be screwed to the roof. So it's quite a nice piece of equipment. I've also got the LNA for it. I have no idea what state it's in. I might send a picture of it offline to this email group and just see what people think it could do. And not steerable, obviously, but I'd like to maybe do some kind of, I don't know what it's called, when the Earth rotates and you're constantly sweeping the sky, using the Earth rotation as your mount. Just do that as a bit of fun over the next year or whatever. I've got too many hobbies. I've taken up home brewing and all sorts of other things. That's kind of where I'm at. And I thought I was retired, but I'm being headhunted, and I would like to take that job, but only as in a part-time basis. So my time, which I thought was almost infinite, my halves again. So anyway, that's my current status. And it's good to be back on the group, and I've got the forward calendar in my calendar, so I get the reminders to the Saturday morning meetings, whereas before it was very ad hoc.
Very
Hey,
good.
Michael, Path with Infinity is infinity. You've got one amount of
Yeah.
time that you take up the job.
You
Well, it
stole my
depends on which
line.
infinity you're talking about. There are a number of different infinities. But yeah, good pickup. Thank you.
No, but in seriousness, I've got one of those little dishes. Mine was an All-Star dish. And what did I do? I bought myself a little RTL SDR,
Yes, I have the, what's it called? The really good one, the $150 one. Not Great Scott, but that crazy guy who can seem to build these things for nothing and then open source them.
Right.
I can't remember what it's called. Anyway, sorry I interrupted.
Right, yeah, got one of those and powered up old the coax at the LNA, and yeah, it can do some sun satellites, and then I've changed the feed on it now. I'm doing hydrogen, but yeah, pretty straightforward.
Yeah, I'm interested in doing
Yeah.
Awesome.
Sounds like, Michael, you will have a story to tell over the next 6 months, a year, or whatever. Keep coming back. And
as long as I
tell us
don't pick up any new hobbies as I go.
Yeah. I'm in a
So,
similar
and the other
situation.
thing, yeah,
Go
the
on.
other thing is I've joined the men's shed here where I've learned how to stick weld, which will come in handy for building any framework or anything like that. Looking good. But there's no Bunnings here. That's the problem. Everything's going to be like a rusty wheelbarrow.
Probably a few of those around anyway.
That's it.
Yeah, the too many hobbies trap is one that I've well and truly fallen into. I was planning over those, so I started tapering off work, going part-time and so on. I've been doing that now for 15 years and still trying to taper. And schools keep getting in touch and saying, oh, can you just do this? Can you just do that? So the retirement point seems to sort of move. It's a variable point, but I collected I collected various interests along the way. And now, of course, everybody wants me to be secretary of this or president of the other and so on. So U3A would throw as much as it can at me and so on. So it's the big change for me, however, is that I think next year I will be doing very close to zero paid work. So that might be a chance to actually get on with some of my own interests. Let's see. Anyway, thank you, Michael. Keep us up to date with progress.
No worries.
Good project. And Rich, that's it from the Australian end, as far as I can tell. So we've Andrew, Phil, Michael, Lynn, and Duncan had to bow out. So back to you, Rich, for the States side of things.
Okay, let's see, Don. Mute.
Oh, mute. There it is. I can actually show my face. Michael, I don't think I would use a wheelbarrow at home for a mount because somebody might figure out something else you could do with it.
Yeah, I was just thinking that the wheelbarrow itself would make a good dish. It won't be optimally a parabola, but it's roughly good enough.
It's sort of a scoop.
With a panel meeting.
I don't really have much of anything. I do have a question, though. If anybody in the group has any experience with the Cassegrain feeds. No. Okay. Just check it. We've shown up here in the States, at least, with some outfit that has turned out some solar cookers. And it turns out that they're 1.5 meter dishes with some mylar on the surface, which isn't going to change much at 1.4 gigahertz, really won't have any effect at all. And they are exceedingly well made. They're steel, and they're for sale for about $70 US and about $30 shipping. And I have a hunch that they are some warehouse buy on the part of these people making the solar cookers. And when they're all gone, they're gone, because I don't see how in heck they could even begin to make the dishes at $70 a piece, let alone coat them with Mylar and fix up a stand to hold a dish and a pot and sell them. I can't see it. So pretty soon they're going to run out. Once they're all sold, they'll be done. I don't see how they possibly make them for that amount of money. Anyway, they would make a nice dish for what I want to do if I can not necessarily have a big weight hanging on the front end. So I decided to try a cassegrain feed. And I wondered if anyone had any experience with it. The equations are out there, and there's 2 or 3 things that tell you they say they know how to do a cassegrain. And I even made the mistake of consulting the Chat GP, which is totally confused by anything real. It doesn't know any mathematics, and it certainly doesn't know anything about RF. So I don't know, except platitudes from somewhere. So anyway, that's all I have from here.
Okay. There, Don, the other
Yeah.
cassegrains, I guess, you get a lot of losses because you've got a subreflector.
Yes.
So that's another problem. But you can go off axis and avoid hanging something over the front, but hang it off the bottom. I guess that's a bit like the TV satellite things. Is it Herschel?
Oh, it's not offset. It's not an offset. It's a central feed that uses, as you say, the subreflector. But the advantage seems to be you can actually gain because the feed is not looking at the ground.
Right.
The feed for the subreflector is looking at space, and so there's no spillover. So I think there may be a gain. See, that's one of the questions I have is, do you want to make the subreflector and the feed horn itself so that you get the 10 dB down at the edge of the parabola, or can you actually use more gain from the main dish itself by having, say, down 6 dB at the edge of the parabola because you're not looking at the ground and increasing the spillover? So somewhere in there is a trade, and I'm not sure where that crossover in trade is, if it's real. So that's kind of the question I really have at this point.
Yeah, you're absolutely right. Look, that's the right sort of thinking. Is the offset thing completely ignored, that won't work. But certainly, trying to find that trade-off isn't.
Right. Okay. Well, I can probably do it. It's just a question of hammering on the math until you can get it figured out. Okay, thanks. That's all I have.
No,
Thanks, Don. Also, Andrew, you guys were wondering where Montana and Colorado Springs is. The picture you had of the WWV, Colorado Springs, is about 100 miles south of that. That's Boulder, Colorado. And Montana, I think, are you 200 or 300 miles north of the Boulder?
At least.
Yeah. So
I'm right on 46 degrees of north latitude.
So Don's north of that WWV, and I'm south. He's about 200 or 300 miles north, and I'm about 100 miles south of that WWV. That's just in the U.S. That's about where we're at. And Phil, I don't know. Are you giving a tour here? I see
we're getting a tour of.
I just saw kangaroos. I thought I'd show you.
Oh, that'd be great.
The kangaroo bounced away.
Well, that'd have been great. I've got deer in my backyard. If you guys want me to do deer, if we ever have it during the show, but let's see. I think Richard Flagg.
Well, I've got a few roosters running down the street, but that's as close as I can come to anything interesting. I don't really have anything to add. I've really enjoyed the presentation, particularly the solar work that Andrew is doing. And it's good to see the 30 foot or 10 meter dish there. I had access to, like I put one of those up many years ago and got some use out of it. So it's always fun to see that. Glad to see the progress you guys are making. Andrew, I had one thing to comment about the Doppler shift on WWV and WWVH. Have you ever had the opportunity to get any records following or during a tsunami, Pacific-wide tsunami?
I haven't looked at them, but I've got records. So I've probably got a couple of years worth of records. And I guess there hasn't really been anything particularly large recently, but happy to, if you've got any times to look at, I can certainly have a look.
Okay, I'll try and look back and see what might be of interest. I had just heard from one of the scientists here that there was some expectation that possibly you could see an approaching tsunami wave, which is really only a few inches high in the open ocean. But I never heard any more about that. And then seeing your Doppler records, I thought about that again.
Yeah, thanks. Yeah, I think that's certainly in the realms of possibility. I mean, the acoustic waves accompanying the tsunami will propagate up through the atmosphere and affect the ionosphere. That sort of thing was seen around the Hunga Tonga volcanic event, more from the explosion rather than the surface waves. But I did read that the surface waves did also have an ionospheric effect. Now, unfortunately, I made the mistake of changing my system that afternoon. And my records aren't that good, and I really can't see anything. But yeah, literally the next day I'd sorted it all out and make the sort of movements I make now. So you can miss out, but waiting for the next one. But yeah, I think you're right. I would expect to see something in the ionosphere. And the way to look at it would be to look at do some Fourier decomposition and look at some of the periodicities in the floor. And in fact, I do that sort of thing. Magnetic pulsations, the PC magnetic pulsations, some interesting work.
Interesting. That might be worth a look. Thanks, Rich.
Thank you. Tom.
Yeah,
Sean.
I'm here and I really have nothing to. I have to admit that strange things happened here with the time change. The Google Calendar spotted it and made the appropriate correction, but the timers didn't go off properly, so I was late getting here. But that's all I can say. Sorry about that. I think I missed some very good part of the presentation there from Andrew, but anyhow, maybe I'll catch it when it goes back up on the YouTube.
Right. And another person who just popped in who loves this is Helen, and she missed the memo on the time change, obviously, because she just showed up. So Helen, you're last.
Yeah, what happened was I had Hotmail and they shut down Hotmail, and we've been trying to resurrect it. And since everybody's been sick, it fell to the bottom of the list. So what, you started an hour ago?
It did.
Yeah.
Well, did I? Sorry. I'm sorry, Paul.
Well, I guess, yeah.
Paul let me know this morning that I had that they had
Okay.
new time.
Yeah,
so.
I'm going to mix your next meeting anyway, because I'm going to have some medical work done. So it'll be the end of November before I get a chance to get back with you. But I'll eventually get I think I'm just going to get a Gmail account, and I've had it. Okay, thank you.
Okay, thanks. A couple of Sarah announcements. March 8th to 10th at the Very Large Array, which is in Socorro, New Mexico, is our Western Conference. On June 7 to 11 at Green Bank is our Eastern Conference next year. And the Eastern Conference will be combined with the Radio Jove team. We did that, I think, in 2017, Richard, but I think we're going to do it again. So we'll have the whole Radio Jove group with us, giving papers alongside us. And the other thing that you may have noticed that in the YouTube channel is that I've got a new editor that actually does translations. It'll dub your voice in different languages. And right now I'm experimenting with German, Spanish, and French. We seem to have a large Spanish group who's viewing all the videos that I've put up there in Spanish. I will probably do that for select videos. I think I only have so many in my subscription I can do. But start watching for that. If you guys have a language you want it combined in, let me know and I'll see if I can do it. Okay, back to you, Paul.
Just picking up on the reference to ChatGPT, I just finished reading Harari's new book called Nexus. I don't know whether people have read Harari. He wrote Sapiens. That was his first book. Excellent book. The 5 aspects of that have contributed to the civilization that we enjoy. Very good book. Then 2 others which were much, much heavier going, but now he's just released Nexus, and it's basically talking about the threat of the rising influence of artificial intelligence, and particularly things like ChatGPT, which is already insinuating itself into our lives, and it's well worth reading. It gives a historical perspective about communication. But then the second half of the book is, all right, what could happen if artificial intelligence starts to basically take over? Will it have self-correcting mechanisms? Will we still stay in charge? Or will artificial intelligence do its own thing and flesh and blood becomes irrelevant? The AI takes over the world. Very scary, worth reading, and just about as scary as the space science stuff that space weather stuff that I've been doing. That's very scary as well. And as Len says, people are believing what ChatGPT is saying. Absolutely. People believe anything they read nowadays. And our friends in America have got a very scary time coming up in the next couple of weeks, I think, along the same sort of lines. I'd be very interested to see the outcome of that. So that's about it from this end. Rich, I think, unless there's anything else anybody wants to chip in to those scary, threatening notes.
Be careful. ChatGPT is not very sentient. Don't forget that when you set up something like a large language thing like ChatGPT, you have to use a training set. And apparently they're pulling the training set off the internet with bots. And it's garbage in, garbage out, and you have to be very, very careful about what you're getting. And the thing about it, the thing about the Chat GPT and its ilk is that you have to know the answers before you start training it.
Yeah.
It can't up anything on its own, I hate to tell you, until they put in some reasoning modules or some other kind of stuff. And even that, considering that half of what it's reading is garbage, we may have even more insane leadership under artificial intelligence than we have under so-called sentient intelligence. I'll leave it at that.
Yes, I think this is the point that Harari is making in the book Nexus. The training, what is it going to train on? And that's the danger. If it trains on garbage, then the garbage in will become garbage out. And as we've known for many years, but just going to reinforce that. It was in our papers this week that the Commonwealth Bank, one of the big 4 banks in Australia, is going to have AI helping the call center operators. So when you ring and you call, and most call centers are offshore anyway, but they're going to have an AI box with them, which is going to help supposedly work out what the person is saying and try and give them advice. And that's very scary. So AI may be eventually deciding whether you get a home loan or a personal loan or whatever. And that's really scary. Same with medicine, AI in medicine. It's all about the training. And if the training is bad, then the outcome is bad. Be very scared. That's enough from me.
I have a little comment to make here. I think somewhere in my computer room, there's a Fortran textbook, which I think was written in the Fortran 2 era, that basically the engineering professor describes computers as high-speed electronic morons.
Yep.
And that's adequate and that's true. And One of the reasons why we can't really make artificial intelligence is we don't understand intelligence to begin with. It's a mystery that what happens in the brain is very much a black box, that things happen and we can see things happen, but we have no understanding of it. So till we can get that understanding, we're never going to be able to replicate it. And I'll step off the soapbox here. This is one of those things that I've been having an arguments about for almost 50 years.
Yep. It's spot on, Tom. That's exactly what it's about. And the trouble is that I think around looking at the people on this screen, I think there's enough real intelligence in this meeting to be able to spot the difference between good stuff and bad. But there are an awful lot of people out there who can't distinguish. They just basically suck up anything that comes along.
I had one little experience where I was trying to calculate the electron gyro frequency. That's the sort of thing I like doing. And I'd calculated, I thought, I'll get ChatGPT to check it. And I think I got results which were several orders of magnitude out. And then eventually, I think I went to ChatGPT-4 and I got a better answer, but it did take some time. But you're right. You need to know the answer that you're looking for.
Yep.
And eventually I got the equation sorted out.
Yes, never ask a question if you don't know the answer. That's their good philosophy. Okay, Rich, I think we're probably there today.
Okay. Thanks, Paul, everybody.
Thanks, guys.
See you in a month.
Cheers,
Roll
everyone.
in.
That was great. Thank you.
Good day, all. Take care.